Hello and welcome back to Maths with Mr. Duffield. I'm going over an exam question on radians for my Deps. This is from the third lesson. Someone was a bit confused as to where the answers come from for this. First of all, let's take a look. Equations 5 sine squared x minus 2 cos x minus 5 equals 0, where x has to lie between 0 and 2 pi radians, this should say. Radians. So make sure your calculator's set to radians. Make sure that you're up to speed with quadratic solving and with the trigonometric identities, because both are required for this question. And also, before we begin, let me draw out a graph that's going to be important for us in this question. It looks like this. That's right. It's the cos graph, ranging between the y values of positive and negative 1, and the x values lying between 2 pi and 0 radians. Why do the x values lie between 0 and 2 pi radians? Because that's the range we've been given in the question. I'll come back to this graph in a bit, but I've drawn it for a reason. Bear with me. So, how am I going to make this solvable? Well, this sine squared x you should recognize as being part of the following trigonometric identity. Sine squared x plus cos squared x equals 1. Take away cos squared x from both sides of that, and you end up with this. Sine squared x equals 1 minus cos squared x. I might note that I can replace the sine squared x in this original equation with 1 minus cos squared x. Why am I interested in potentially doing that? Well, if I have a cos squared x in this equation, and I also, as you can see, have a cos x in this equation, that becomes a quadratic that is solvable, because cos is a constant term between the squared and this term here. So let's do that. It effectively becomes 5 times 1 minus cos squared x minus 2 cos x minus 5 equals 0. Okay, all that I've done is just replace the sine squared x in the equation there with 1 minus cos squared x. That's it. The rest is multiplying out this single bracket and seeing where the simplification takes us. 5 times 1, 5. 5 times minus cos x minus 5 cos squared x. Excuse me. Minus 2 cos x minus 5 equals 0. You'll note there's a positive 5 and there's a negative 5. Cross those two out because they cancel. I'm left with minus 5 cos squared x minus 2 cos x, excuse me, equals 0. I can effectively make those positive. I can change the signs to positive and it will say equivalent. You can think of that as timesing each term by minus 1. And because every term, the minus 5 cos squared x, the minus 2 cos x, and the 0 are being multiplied by negative 1, it all stays equivalent. I end up with 5 cos squared x plus 2 cos x equals 0. And now that this is in this form, well, I can factorize this, because there are common parts of these two terms. The common part is cos x. What do I times cos x by to make 5 cos squared x? The answer? 5 cos x. What do I times cos x by to make positive 2 cos x? The answer is positive 2. I'm going quite quickly here, but hopefully you can see where I'm coming from. I first replaced sine squared x with 1 minus cos squared x from this identity, slightly rearranged, expanded out the bracket, simplified, and now once that has been simplified, factorized by taking cos x out as a factor. So, just like every other quadratic we've ever solved, this is a thing, this is a thing, they're being multiplied together, the answer is 0. One of these two things has to be 0 in order for this to work. So either cos of x equals 0, or 5 cos of x plus 2 equals 0. Okay? Making some rearrangements here before I turn the page. Obviously, cos x equals 0. I'll leave that as it is, but this can be rearranged. If I take away 2 from both sides, 5 cos of x equals minus 2. Therefore, cos of x equals minus 2 over 5. All right. At this point, now that I've got these two kind of trig elements, I'm going to take a look at this graph. Because we're dealing with the cos kind of functions down here, I've got to deal with the cos graph to make sense of this. Cos x equaling 0. Well, that is a line drawn through the y-axis at 0, intersecting with the graph here and here. These two solutions are indeed the two solutions for cos x equals 0. If you were slightly confused by that, if you take inverse cos of both sides, you end up with x equaling the inverse cosine of 0. The inverse cosine of 0, you can do that on your calculator if you like. It gives you pi over 2. But it also intersects with this part of the graph, which, if you've spent any time looking at the way these graphs behave and what the key points are on these graphs, you'll know that the minimum is where x is pi, and the two x-intercepts between 0 and 2 pi are pi over 2 and 3 pi over 2. So those are two solutions for this equation. The other one we had was cos of x equals minus 2 over 5. So x equals, in a similar manner to what we just did before, the inverse cos of minus 2 over 5. Now minus 2 over 5, the line that goes through minus 2 over 5, will go something like that. Intersecting up and creating 2 points here and here. Now I know those aren't perhaps as clear as they could be. I'm not Pablo Picasso. This isn't the best drawn graph, but it is a representation of what's going on. So let's do it. Inverse cos of negative 2 over 5. Let me type that into my calculator. It is set to radians. 1.98. Yeah, 3 significant figures is fine. 1.98 is there. Slightly more than half of pi. 1.98. That makes sense, doesn't it? So if I find the difference between, just bear with me, if I find the difference between 1.98 and pi over 2, this gap here, if you can see, this little space here that I'm indicating, if I find that little gap and I take it away from 3 pi over 2 over here, then I'll find that other root, the other point where minus 2 over 5 intersects with this cos graph. And that's important. So that gap is, having just taken away pi over 2 from 1.98, it is 0.411 and continues. If I take 3 pi over 2 on my calculator, okay, and subtract that answer from it, I will get that other intersection point, which is 4.3. 0.87 and so on. So obviously 3 significant figures, 4.3 is fine. So what are my solutions? My solutions are pi over 2 and 3 pi over 2 for the cos value associated with 0, and, or, because this is a quadratic, 1.98 and 4.3. Okay, so there are actually 2 pairs of possible solutions depending on which one of these brackets is equal to 0 in this quadratic. Okay? So much going on here. It's brilliant. You've got substituting in a trigonometric identity to form a quadratic. You've got the expanding and simplification to make this form that you can factorize. You've got the consideration that they multiply to make 0, to set each of these cos equations equal to 0, rearrange. You've got the graph consideration to work out where it is intersecting with the x-axis and where it intersects with the graph to be read to the x-axis. So much stuff going on. Making it my longest video yet. If you have any questions about that, please let me know. I appreciate it's confusing, potentially a little bit overwhelming, but I believe You'll be absolutely fine. Keep working hard, and keep asking questions, and for goodness sake, keep uploading your work to Teams. I will talk to you very soon.